So today, as-built drawings, and Colin Maloney is an expert on this, and looking forward to what you have to say, Colin. Take it away.
Thank you so much, Donald, and thank you to all of you for attending. I'm going to kind of go through a few formal slides, repeating myself and repeating a little bit of that. So let's just get started right away, shall we? Let me get my slideshow going. Hang on here. Okay, and there it is. All right, can everybody see that cover sheet?
I can.
Okay, yep. That's good. I'm gonna just try to expand the video so I can see some of you when I'm doing it. It always goes away and it's very annoying. Let me see here. Okay, there we are. Okay. All right, so hello, welcome to the AIA East Bay Small Firms Forum. Today we'll be covering best practices for surveying, drafting, and modeling as-built plans. I'm Colin Maloney. I'll be your sole presenter. I'm the regional director for the Bay Area, actually Northern California Office of Precision Property Measurements. For over 20 years, this company's been delivering as-built surveys to architects like you all over the country. Given my tenure in the industry, I've been fortunate enough to observe the production methods change over time. So during this presentation, I'll impart not only some of the best practices, but some of its history and evolution as well. So these are just kind of some formal things. This class is a demonstration of how to procure a proper set of as-built plans when needed for any structure. It'll briefly cover the reasons, the technique for obtaining the information, including 3D laser scanning and traditional methods, and finally the drafting in CAD or modeling in Revit to suit your design needs. At the end of the course, you should be able to begin a project by determining if as-builts are needed, obtain the as-built plans for all levels of scope through some traditional but also fundamental methods, understand some of the newer methods for gathering data on site, such as lidar scanning and 3D photogrammetry, and put down collected data into both AutoCAD and Revit. All right, so let's start off with a little table of contents here and talk about what we're going to cover. What are as-built plans? We'll talk about common definitions, when as-builts are needed, gathering various degrees of information, and the details of the scope that may be needed. Traditional surveying methods, we'll discuss sketching, plan view measurements, and getting that Z-axis stuff. Laser scanning, the new era. We'll discuss terrestrial scanners versus mobile scanners, point clouds, and using point clouds. And then creating the actual as-built set, drafting. So throughout the presentation, we're going to have a series of polls. And I'll ask you a multiple choice question, and at the end, we can open it up for questions, just in the interest of getting through this entire presentation. So we'll save the questions to the end, and I'll try to get through it quickly enough to save some time for that, all right? What are as-built plans? So let's start by talking about some common definitions. When looking into the actual definition of as-built plans, what one will mostly find is a definition that concerns as-built plans being created after or during new construction, or after during a renovation. So as-built plans are prepared by the contractor. This is the definition. They show in red ink on-site changes to the original construction documents. They are more like interpolations done for the construction purposes. Therefore, the changes that the contractor makes onto the original design are called as-built drawings. Contractor developed as-built should not be confused with record drawings, created, of course, by the architect or engineer. Record or archive drawings often include the information gathered on as-builts and are the final set of formally developed prints, fully signed and stamped by the project engineer. This definition reads, this set is not always mandatory and created, but in general, some formal architectural services create these as one of the last tasks of a building project. And of course, everyone here takes the time to do that every time, right? So we're going to take a poll here. How many times has a contractor that any of you have worked with created as-builts for you as described? And the three answers are A, never, B, sometimes, or C, always. Okay, so let me see if I can launch this poll here.
I took care of it.
Oh, you did. Okay. Oh, and look, people are answering. Thank you so much, Sydney. And yeah, thank you for answering, everyone. Looks like I think we've got just about everybody in there. So it's not surprising. Let's share the results. Can everybody see that?
Yes.
Never. Maybe one person had one occasion where that happened. Okay, so not surprising. So we're going to move on and we'll see what I'm getting at by asking a question. Okay. Is it still displaying on your end? I can't see the poll. No. Okay. There we go. All right. So again, what is an as-built plan? Let's just keep this simple. I think we all can agree. Simply put, in the architecture and construction industry, as-built refers to a drawing that shows existing dimensions and conditions of a building, space, or area. Sounds agreeable? All right, so before we get any further, I want to say that throughout the presentation, we'll be discussing producing as-built plans in their final format as either 2D CAD files or a 3D Revit model. Both are softwares created by Autodesk. And as likely you will all know, there are many, many other drafting and modeling softwares out there. So even though I mentioned Autodesk software, it's likely you can apply any points I make to 2D drafting software on the market or 3D modeling software. So just keep that in mind. Even though I say CAD or Revit, I'm talking about, you know, just about everything. So when are as-builts needed? Pretty much whenever you're working with an existing building, we need as-builts before starting your design. If the owner or client happens to already have as-built drawings, then we may just need to enter them into CAD or reformat them if they're already in CAD and confirm that the drawings are up to date. If errors or inconsistencies are found, then at some point you may decide a fresh set of as-builts is needed. When aren't as-builts needed? What are the contributing factors? It's rare that clients already have current as-builts of their existing building that are accurate, but it does happen. So in that case, you would not need more before starting your project. There's also simple cosmetic projects that don't require having accurate as-built plans. And of course, if a building's being built from scratch from the ground up, then all you're going to need is the construction documents that you create. When is the best time to obtain as-built plans? In most cases, obtaining as-built files is one of the very first steps in the renovation, if not the first step. Getting ahead of this step allows an architect to focus on their design, plan creation, and submittal to the building department, all of which are considerably more time-consuming than the first step. There are also cases where you'll be working with a historic review board, and they will often require as-built to be created, especially those exterior elevations. Most engineers will want a fresh and accurate set of as-built before they begin a seismic retrofit project. And if you're working on a teardown project, some building departments require you to submit as-built of the structures even being demolished. We've seen that before. Other contributing factors to needing as-built. As mentioned on the previous slide, different municipalities work differently and have different requirements. If they work, if they require as-built for any reason, the type or scope needed may vary from city to city, and even sometimes within person to person within that city, I've found. If you plan to preserve or improve upon detailed architectural elements such as ornamentation, you'll need to consider that documentation and where it fits in your timeline. Overall, the size and scope of your project will determine when the as-built are needed. And as we'll discuss in the next section, to what degree the detail and scope of the as-built are required. So you've discovered you'll need as-built. How far or in how much detail do you need to go? So above are some examples of plan types and when they're needed in your as-built set. You may need floor plans almost always, exterior elevations when it impacts the exterior, sections on an existing structure where there may be height constraints you're working with, such as attics, basements, or crawl spaces, reflected ceiling plans when you're modifying the lighting but not replacing it completely, and where there are unique ceiling conditions that you're working with, such as coffered ceilings, exposed structural members, etc. It's ultimately up to you as the architect to decide what the scope should be for your as-built plan set, or consult with your engineer as well on what is needed. Before we get into specifics regarding the plan types, let's go over some of the ways to gather on-site information, starting with a very simple, quick method, and then ending with full-blown as-built plans. We know what we need, why we need it. Now, how do we get it? Okay. Perhaps just photos only. One way to obtain the answers you need on site before renovation is simply by taking photos. This can assist in the design process and answer questions you might have before proceeding. Sometimes a quick single line or bubble diagram is all you need to achieve your goals. This can be achieved quite quickly on site and doesn't need to be to scale. Sketching can be very helpful in supporting your design in the case of interior elevations or perspectives. This can be done roughly and may not require any actual measurement. And then there's measurement. If drawings need to be to scale, such as when they'll be used to create the new construction documents, then you'll need to go to a higher level of accuracy and measure the existing conditions. Most remodel projects will require a more detailed scope for as-built. This will give you a head start in the creation of your design, submittal, and construction documents. And to sum up the first portion of this presentation, as-built plans, simply defined, is a set of plans of any structure as it exists in that moment. They're most often used for a renovation of some type. Getting as-built drawings in the format in which you work is important, such as a particular software. The scope of the as-built plans and the detail of each scope item will vary with the needs of your project. Okay. We're going to talk about traditional methods, and we'll start with an as-built production method that's near and dear to my heart, sketching. Believe it or not, I miss it. So here's how you might sketch. Remember that sketching does not need to be to scale. All you need to do is make sure that there's room to write all the measurements you need and that it is visually easy enough to follow when you're back in the office. Using different colors to mark different measurements and drawing types is helpful, so that your eye will catch each segment accordingly when drafting, and you don't spend as much time hunting on that sheet of paper for what you need. Getting as much sketching done before you measure is recommended so that you can just focus on measurement when the time comes and execute. You kind of go from one thing to the other. The better your sketching is, the easier your measurement will be. If sketched well, any structure can be measured quickly than if not. Plan ahead and get your heights or your Z measurements as well. Most of the time, this information can be displayed in plan view, but occasionally you'll want to sketch this in section or elevation view. We'll talk about this again in the next few slides. Sketch out any details or ornamentation to the degree of precision you desire to be able to add those measurements later when you're drafting. So now it's time to measure your sketch. An important step that many people skip when measuring a structure is going around the exterior faces. Often wall thicknesses are taken at an exterior and then the interior measurements only from there on out. I consider this step here to be crucial. So start with the perimeter or exterior faces. Measure all the lengths and 360 degrees around until you get to the point where you started. To check your work, add up all the X values and all the Y values. You can see I've done that in this sketch below in the lower right. That's what that is. I've added up the X values on the top, the X values on the bottom, the Y values on the left, and the Y values on the right, just to see how close I came. That gets you to your closing error. If the sum of all X values on each side of the building add up to the same number or very close, then you're right on track. And yeah, do it for the X and the Y. Forgot about that little animation there. Okay, so plan view measurements continued. Well, in this sketch, you'll notice there are some overall measurements as well as small incremental measurements. This is a good system of checks and balances that will not only improve your overall accuracy, it may save you in the event that you have an incorrect measurement or notation. Don't forget to get good photo coverage as well. That will help you verify that what you're drafting is indeed correct. Occasionally, I've seen errors that don't appear as errors on paper, but are very obvious when looking at an image. So that's a way to back yourself up. And yeah, again, in the sketch, the red measurements are the overalls. The ones in pencil are the little incremental ones in between. Okay. As you can see, this image below shows the previous sketch, but with a sheet of vellum on top of it. This allows you to use the information from the first sketch and mainly the sketching, the line work, such as the wall layout, and then add even more symbols and measurements above that. So obviously little symbols for electrical faceplates, reflected ceiling plan items, and things like that. Now let's talk about collecting the Z-axis measurements or the height information using traditional methods. You'll need your heights. Okay, so yeah. You can use a tape measure to measure all the risers in the stairs, or drop it down a balcony, run it up a wall, etc. A laser distance measurer or a disto can perform trigonometric functions instantly and get you heights in all sorts of ways. That's one of the ones that I prefer, the Leica disto. It's a Swiss camera company, I believe, but they make lasers. The first two tools are ones you've already used probably in other aspects of your plan, but the third is used exclusively to gather height information. It's called a zip level. This is an excellent tool invented, distributed, and repaired if needed by a company out of San Diego. I'm not aware of any other version of this tool. It uses displacement to read heights anywhere within a 50-foot radius. It's got a cable in the middle of it, as you can see. The readout dial is below. However you've collected your height measurements, make sure that you got them in the places that you'll need them. Most of the areas will be obvious, like the tops of any steps or staircases. This is an example of, that in plan view. So floor to floor heights, any changes in the finished floor height, that sunken living room. So plan on what you'll need to see in those exterior elevations and sections as well. Make sure that you either have some height and some good picture information for your roof, or every height if you can get on the roof, if it's safe to climb around there. Make sure not to forget the heights of openings such as windows and areas you plan to show, or the heights of things like a sconce on the wall if you plan to produce detailed interior elevations. That sketch of the roof is one that is just basically showing what a zip level would look like, a zip level sketch to get heights. You got your measurement on the eave and your measurement at the ridge. And as long as you know the X by Y measurements of that roof, that's all you're going to need to construct it. It's the same as, I was discussing, I believe, with Barry earlier, that, getting the degree measurement and the X by Y measurements will also help you produce the pitch and the height information as well. But the zip level is a little more definite. So to sum up the second portion of this presentation, overall, having the perfect sketch isn't important. What you need is a sketch that displays and contains all the measurements you'll need in drafting. You'll need to encapsulate the structure by measuring around it. This will give you the scale when you begin drafting and ensure that your interior measurements are correct. You don't have rooms popping out of the exterior if you did something wrong. After taking the measurements of more major items like walls, doors, and windows, move on to the next level of detail as needed. This can be for cabinetry, plumbing fixtures, or even electrical and ceiling components. And I'm realizing that a lot of these examples are of single family homes, but you can apply this to any commercial structure as well, everything I'm talking about. So we have another poll. How comfortable are you with sketching and measuring as-builts? And the available answers for you are very uncomfortable. It makes me sweat just to think about it. Or B, I've done it, but I don't like it. C, I am comfortable doing this. And D, I always sketch and measure my as-builts. I love it. And when we do Q&A, I'll have one question for you as well, in addition to this poll that's kind of along this lines. I'll just have an additional question kind of similar to this one. Okay, we're getting some interesting results here. I'm liking this. We got 100% of answers. So let's see how we did. And yeah, so 42% of this crowd has done it but doesn't like it. 25% are comfortable. And then we have a pretty significant group that always sketches and measures their as-built. So hopefully at least something from this presentation so far has been helpful to you. And then if you have more questions, I can share what I know about these methods. But we're going to move on to some other methods now. Laser scanning, the new era in obtaining as-built information. The change to a completely new technology and ditching some, if not all, of the traditional methods isn't easy in any industry. And I was admittedly skeptical myself at first, but using lidar allows for fast data acquisition performed by a skilled surveyor using 3D laser scanners. More accurate than any field measurements can be taken by hand. It reduces the odds of human error dramatically in the field. And we all know about that, I'm sure. This technology can be purchased, it can be rented, it can be contracted out. It's a thorough solution. It always allows surveyors to gather more data than needed to complete most projects. And it provides that digital twin to pull additional data down the line if the project ever needs to be revisited or additions need to be made to the scope of work. Here are some examples of each type. The terrestrial on the left, a standing scanner, or the mobile, which is a walking scanner. Either way you choose to go, you'll be using lidar to create a point cloud. LiDAR is a method for measuring distances by illuminating the target with a laser light and measuring the reflection of it with a sensor. Each one of these illuminations can be considered a measurement. Each single measurement is logged, usually in some sort of data logger, and throughout the course of the scan, millions of measurements are taken in all directions. So let's talk about, for a minute, a terrestrial scanner that I'm familiar with. There's many kinds too, just like the software discussion earlier. There's whatever I show, there's an equivalent probably for what you've heard of or the brands that you've heard of. So overall, you'll find, this is the Leica BLK360. Overall, you'll find that terrestrial scanners like this one will give you a much more rich, dense point cloud than a mobile scanner would. Some terrestrial scanners offer extremely high level of precision to their clouds. In the next slide, we'll see a short video of a scan of a single family residence taken with this exact scanner right here. And I hope it works. Here we go. Oh, I'm gonna go back. Let's make sure I can, oh, here we go. There we go. As you can see, it collects a lot of data all around as you scan. Scanner picks up, this scanner in particular picks up color as well and has a thermal detection capability. If you're interested in measuring for that sort of thing, you can see where hot air or cold air is leaking out of certain parts of the structure for whatever reason. I think you can detect some water leakage, things like that as well, but you can see it's a very rich cloud, and color is of course included. You can see the green in the trees. Now we can touch on the scanner I'm most familiar with. This is the GeoSlam Zeb Revo. The trade-off for a less dense point cloud or a hyper level of precision is that with a mobile scanner, you greatly reduce your time on site scanning and increase your mobility since you're moving. And the scanner does not need to be mounted to anything. You can even mount other equipment on them, such as a GoPro camera, or mount the scanner itself to a drone. Sorry, I went a little too quick. So next, we're going to watch a short video displaying the output from a scanner like the one you see here. And that last check mark there, I want to mention that GeoSlam has produced scanners that get closer to a 1/16 of an inch precision in the cloud itself. So with that Revo that you see in that photo, that was, you know, a reliable amount. But and again, it does, the construction quality will make your point cloud vary in other ways as well. So yeah, let's watch this video. So this is some footage of the mobile scanners output. You may notice that the coloration of materials isn't included, but it does have a height ramp visibility where different heights are shown as different colors on the spectrum. So it's turning from a yellowish to a bluish as the height goes up. And this is also a very, very large point cloud of a very, very big single family residence that we did in the past. And that is the output on that one. I know there's some pixelation as the videos come through since we're streaming this, so hopefully that wasn't too rough for you. Using a mobile scanner is preferable if time on site is limited. It gives you the ability not only to scan the project quickly, but to have time to process the scan on site and check the results. Once the scan is complete, you need to process it using the software that is essentially an algorithm that interprets all the measurements and arranges them into the point cloud. Reviewing your complete point cloud on site is essential to ensure accuracy. Most errors in scanning or processing can be spotted quickly and actions can be taken. This will ensure overall accuracy in drafting and modeling later. So now let's talk about this infamous point cloud, shall we? Reviewing your data well before attempting to create a set of as-built from a point cloud is a must. If there are any kinds of errors with your cloud, which do happen, then using the bad data can either stop you in your tracks later when you're drafting or modeling, or even worse, result in an incorrect set of as-built and change orders and all sorts of problems later on. Once your scan is processed, you'll need to review the output. Did you cover all the areas? Are there any flaws or errors? You want to ensure there is no drifting. Make sure to look for any drifting which can occur when the software has trouble putting all the points together. If this occurs, then you can try some reprocessing options or simply just scan the structure again. Drifting is common with mobile scanners, and it occurs for several different reasons. Determining which reason is helpful before attempting to reprocess or rescan your project. And in this case, you can see that the exterior wall does not in fact bend like that, and it took all the exterior information with it, including the sidewalk and the trees out there. When scanning attics, foundations, large sites, multi-level structures, etc., you may run into issues. Areas that are harder to access or have less unique features like repetitive hallways or lots of reflective surfaces can cause issues. Processing requires all areas have data connecting one area to the other, so they can properly be glued together. You got to think of it as kind of like the data has been logged and now they have to glue the point cloud together. Mirrors, moving objects, people following you, big trucks can also trick the process and therefore give you bad output. Most scanners have a pretty far range shooting out of windows, and when outside all over the area, you may need to clip or crop the cloud to reduce the size and delete any unneeded data. And if you have taken multiple separate scans for whatever reason, knowing how to merge separate clouds together is useful. One of the main reasons for needing to take separate scans is just because it's taking so much data down, and if you're running the scanner too long, it just won't work. So you're limited by time. This is talking about the mobile scanners. If you use those terrestrial scanners on a tripod, you're going to be merging no matter what, or it's actually called registration. Much like the traditional method of sketching and measuring, properly scanning a structure takes lots of practice to do correctly and efficiently. Once you are practiced with scanning and know what to look for when errors may have occurred, you will have the most reliable version of data you can gather in the field. You can be confident that the as-built plans you create will be fully accurate and ensure a smooth and safe renovation as it progresses. Using the point cloud. So now that you've processed and reviewed the outcome of your point cloud data, you'll need to do one of the following things. Do it all again if it came out poorly, or go back to your drafting and modeling station to get started with the next phase. Cut sections. So in order to produce items such as a floor plan, you need to be able to slice the point cloud in the desired section and work from that. Most software allows you to do that pretty easily. View from all directions. In addition to cutting sections, you'll need to be able to move or rotate the clouds to give you the working angle you desire. Scanning your project, in summary here, can reduce errors and time spent on site. The type of scanner you use will be dictated by your needs and the level of detail required. Your scanner will create a cloud made up of millions of points. Knowing how to manipulate it is crucial. In this way, it will have utility once brought into your preferred software. So just an added note here, my perspective has been that almost overnight as-built production methods have shifted from traditional, done that way for decades, to utilizing the latest in laser technology. As with every new introduction of production methods, there's a learning curve, but once mastered, the entire process gets much smoother. When incorporated with BIM technologies, the entire construction process can get a boost in speed, efficiency, and a lesser environmental impact. Now that you've collected the measurements in the field, whichever way you did it, it's time to create the actual as-built plan sets. It's important to keep these organized and concise, but at the same time, leave room for notes, building code information, etc., so that they can be used for design layouts, demo plans, construction documents, etc., as discussed earlier. I know that we've recently been talking about scanning, so now we have to shift gears and go back to that traditional method just for a little while, and how to translate those sketches into great as-built plans. Prop your sketch up next to your computer and fire away. Pretty straightforward process. You use a vector-based drafting software and draft to full scale, entering the measurements from your on-site sketch. If modeling in Revit from a sketch, it's more difficult, but it's not impossible. You are building rather than drawing in that case. So you'll often find that you need to let the model dictate certain measurements rather than your own. For a floor plan, you'll be using primarily the line tool in combination with whatever blocks you've created. Perimeter line usually comes at first, as it does in the field when you're measuring. You'll want to draft your walls first, do maybe offset, copy them in according to your thickness measurements, and then add your windows and doors. If there's multiple levels, you'll not only need to draft using your measurements, but also be very cognizant of those stairwell walls and exterior faces of the structure to make sure that they line up exactly as they do in real life. I don't probably need to tell any of you this, but when you're going down the stairs, if you can rub your hand on the wall and it doesn't bump out or whatever, then it should be the same line on the first floor in the exact same position as it is on the second floor. Once those controlling items are done, you can draft in with perhaps a lesser degree of precision, cabinetry, plumbing fixtures, appliances, etc. For an electrical and reflected ceiling plan, it's much the same. You just follow what you've sketched and measured and add those items one by one. And then another thing is I like to take a highlighter and highlight on my sketch each of the little lights and light switches just to know that I've put them in the drawing. All right. Oh, I'm going way back. Oops. You'll need to be at least, you'll need to have at least sketched the behavior of the roof correctly in the field or by using a nice clear satellite photo to draft your roof plans. But, again, the measurements should be on the sketch. This means all the hips and valleys and ridges, directions of any slopes. This and the measured length of the overhang should get you to a place where you can draft the roof in plan view. On the same roof sketch, you'll have wanted to collect all those height measurements. It's often used by using the zip level, which I mentioned earlier, and actually getting on the roof to take all the needed height readings. There are other methods such as using an angle finder, a level, or the various functions on that disto laser. Drafting elevations will come entirely from your floor plan and roof plan sketches at that point. The only exception is the special sketches which show certain aspects of ornamentation on the exterior. Drafting elevations will entail placing all windows and doors correctly with the correct heights. And of course, it's important to ensure they correspond directly with the floor plans in those cases. A lot of people use the pinwheel technique. They'll rotate their floor plan 4 times and drag the lines down. Any decorative items you've sketched and measured can be drafted as well. Drafting a roof in elevation view is one of the most difficult challenges. It needs to correspond perfectly in all other elevation views. Oops. Sorry, I'm clicking a little too fast here. Once the cut location and direction are determined, you'll use the floor and ceiling information you've sketched and measured on site to complete the section view. To draft the roof properly in section view, it's highly advised to have your elevation drawings finished first in order to use them. You can see that there's even some hatched exterior elevation info used in this section in the background. Now we can shift our thinking back to the scanner method and doing this work using the point cloud that we've created. If you use laser technology to measure, you'll be drafting from a point cloud. This can be imported directly into your CAD or Revit software. Autodesk requires that you use another software called Recap to prepare the point cloud for the import and ensure it works with their software. Drafting from a point cloud in CAD is pretty straightforward, but it takes getting used to. Modeling from a point cloud in Revit has a few less options. There are lots of options in CAD to adjust the cloud in different ways. You'll need to use the view cube, rotate your UCS orientation properly to work with the cloud in different positions. Since the entire program Revit is focused on modeling from a particular view range, those of you that use Revit are probably familiar with view range. It allows you to manipulate and model your cloud simultaneously. It's all just kind of one thing. First, we can talk about drafting the plan view items from a cloud. When drafting in CAD from a point cloud, you want to ensure that your cloud is positioned orthogonally so that you can use the ortho function in CAD to draw lines. Positioning your cloud on the Z-axis as well is also desirable for several reasons. You should be able to derive all the walls, doors, and door swings right from the point cloud. Window information can be found as well when you are skilled at reviewing point clouds. Many scanners will not pick up smaller items, especially if they're flush with the walls or the ceilings. So trying to locate them in the cloud can be very time consuming in that case. So oftentimes it's better to revert to the traditional method when in the field and just sketch and measure these items. With windows, I prefer to measure those by hand as a backup, just because, you know, you got curtains, you got Venetian blinds, all these other things to contend with, and getting correct window sizes is important, especially to architects. So now let's get into drafting in other views, such as the elevation, the roof, and the section from the cloud. This is where having a huge advantage in point clouds for drafting is apparent, provided that you are able to access the roof in scanning. You will have a complete picture of not only the roof behavior, but also every height you'll need to properly draft your roof, exterior elevations, and any sections you might need. As with electrical and RCP, sometimes it's beneficial to revert to those traditional methods to sketch ornamental items that you'd like to include in your drafting. You can see from this cloud, it kind of looks like mushy spray paint. So, you know, if you got cornices and trim and things like that, you might want to be taking really good photographs and even sketching some of it. Let's briefly discuss the Revit as-built model, or the 3D model. Level of development system, I just want to take a second to talk about this, was created for the AEC industry to put standards on BIM drawings. They're just trying to wrap their heads around this. It rates the precision, detail, and overall refinement you can take your model to, with level 100 being the lowest, meaning you just use mass to create your objects very roughly, and level 500 is the highest, being so detailed you're essentially building a virtual version of the structure. When modeling as-built plans, LOD 2 to 300 seems to be the applicable range, since you're assessing a structure that has been built from the outside. All interstitial spaces are inaccessible, and their construction cannot be assumed, at least not by me. Maybe some of you out there want to make those assumptions. Oh, oops. So when electrical and RCP elements are needed in your as-built model, they'll likely be drafted into the plan set in a similar way to CAD rather than 3D Revit. The items are placed correctly in their 3D locations, but may not have 3D functionality themselves. You can build that into it so that if you use such, for example, the camera tool or interior elevations, you're looking at a light switch and it's actually at the correct height off the finished floor and all that good stuff. So in the case, Revit has many tools to build site plans and add topography if needed. If you only plan to model the as-built of the structure, you may want to limit your site work to the areas that surround or touch the structure only, if at all. In the case that exterior elevations like this one, you'll want to make sure that the finished grade is accurate along the face of the house. This can be achieved without going into all of Revit's topography tools, and instead just using some of those drawing tools. There are some advantages to having a BIM model as built, which some may not be know. Sometimes a three-dimensional model is only considered for presentation or design purposes, but it also can be useful in an as-built as well. The as-built BIM model already has the existing phasing, so you can dig right in and start a project using their powerful phasing to show demo and proposed. There's no wasted time moving from the design phase to the construction documents phase of a project. Having an as-built BIM model can make it easier to understand the project that you haven't visited yourself, since you can cut sections and view the existing spaces and roof massing in 3D. And some say Revit offers a more intuitive design experience and allows users to present 3D images at the planning stages to the owner or planning departments. So to sum up the fourth portion of this presentation and this presentation altogether, drafting from sketches into CAD is a pretty straightforward process. It takes time to become efficient, but you'll just be entering measurements into CAD straight from your sketch sheets. Modeling into Revit from sketches can be done, of course, but you may find during modeling that you need to ignore certain measurements in lieu of letting the powerful software build the model properly. As some of you may know, Revit kind of tells you what to do sometimes. Drafting from a point cloud in both CAD and Revit means that you'll be importing the cloud itself directly into the software and essentially tracing or placing components right on top of the cloud to create your set of plans. So before the Q&A, one question that you can all put in the chat your answer to that I'm curious about is, when you went to school for architecture, did you have any sort of classes you could take on as-built or how to properly measure buildings? And yeah, that's just something I'm always curious about from others. So yeah, let's open it up to some questions. I think we do have some time left, if I'm not mistaken. And since there's only a few of us, maybe we'll just shout them out.
Yeah, that's nice.
Colin, we have until 1:30, so there's really quite a bit of time.
Excellent. Excellent. So yeah, go ahead. Let me see. I can't really, I don't know why, but I can't expand this thing all the way to where I want it. Oh, wait, there we go. All right, so looks like Mr. Wagner has his hand up. So yeah, go ahead.
You can call me Barry, that's okay.
All right, Barry.
So you talked about Revit. Vectorworks, same thing, just a different kind of import process, or?
Ooh, that is interesting that you brought up that one. I think only recently could you do this with Vectorworks. They were kind of the last holdout 3D software that you couldn't import point clouds into their software for a while, but now I believe you can. So you shouldn't have any trouble with that. In fact, I was just in Chicago. I don't know if any of you were in Chicago for that AIA event, but I got to meet with some staff at Vectorworks and we were talking about it, and they're fully ready to go importing point clouds into their software.
Second question is, can I borrow your Leica terrestrial every so often?
Man, you know, if it wasn't so expensive and precious, I would say yes, but
Maybe
they are available for rent, you know, and you can contact Leica, and like Leica, they have somebody who is a local distributor or rep that you can talk to about renting for a fee.
How much are they?
That I don't know. The scan to purchase that BLK terrestrial scanner, I think is somewhere in the neighborhood of $20,000 to $25,000.
$25,000.
And that will include their software suite to do it, because that's the important part. The scanner is expensive, but the software that it uses to, as I was mentioning, glue the cloud together and also register multiple clouds, that's where their real asset is, believe it or not, beyond that.
A third question, sorry to push out everybody, but when you are tracing over the point cloud and then you put a dimension between the inside faces of the walls of a particular room, what you talked about some accuracy of an 1/8 of an inch, a 1/2 inch, a 1/16 of an inch. What accuracy do you have? Because you're really tracing over something. You're not really, I mean, yeah, that's the question.
No, that's a great point. So you got two sets of precision there and accuracy. You got what the cloud gave you, and then you got the decisions you're making. So in viewing some of that mobile lidar scanner cloud data, you might have noticed that the walls are a little bit fuzzy.
They're fuzzy, exactly. Fuzzy by how much?
They're fuzzy. Well, okay. So the scanner itself, as I mentioned, will say, you know, they're down to the 1/16 of an inch precision. You've got different things at play though. Is the wall plumb? Does it have, you know, paint? Does it have stucco? So that usually results in some of the fuzziness, but you know, whatever that is on the package that they advertise for their precision, if you're looking to get very hyper precise, you're going to want to go with something like a Faro terrestrial scanner. Those are going to run you about $60,000 to $70,000. And then you're talking about a cloud that does not mess around, and every point that it takes is going to be right in the spot where it is to sometimes the 64th of an inch.
So the fuzz on a less expensive terrestrial scanner, that fuzz, if you were to measure the thickness of that fuzz, what would the thickness of that fuzz be?
It's usually within an inch or less. And what you're going to want to do is just smack your line right in the center of it. And then you can be very, very confident that that line is useful for architectural purposes. All right. No, you get cut off. If you have more questions, you're going to have to hold it. Donald, you have your hand up. Go ahead.
Yeah. In the spirit of sharing how we do things, what I notice is that my way of doing things is totally different than what you have described, and that both your low-tech, sketch, and high-tech methods are similar in a way that's totally different than the way I do it. And the similarity is that you're basically doing on-site measurements and office production of drawings. And I used to do that for a while, but for the last 25 or 30 years, I've not. And what I do that's different is I go out in the field with a laptop and a Wacom tablet. And if it's a large project, I also have a desk height rolling cart that works like a desk, and the measuring tools, a tape measure and a disto. And I measure and draw into my CAD program on the site. And so it does some things. One, it eliminates errors that you get with sketches, because if something can't be there, you'll see it when you try to draw it. And the second thing is that when I leave the site, I actually have the drawing, and I don't leave until I have the drawing. And the next observation is that this might be peculiar to my work, but what I need in terms of information is different at the beginning of a project than at the end of the project, because of the kinds of things that you're concerned about. And so I basically, in most projects, I'll make multiple visits to the site at different time as the project goes along and we get into, deeper and deeper into what's going on. So in the beginning, basically, I just need a good floor plan, maybe some site information and some vertical measurements in the windows and stuff like that. As time goes on, I go back and I get more detailed information. And the last thing I would say is, you mentioned on the sketching, always doing the perimeter. I never measure the outsides of things. I measure everything from the inside, and the outside is determined by what the inside is. And in this method, all the wall thicknesses are accurate because you measure them with the tape measure at each situation. That's all I wanted to say. Thanks.
Yeah, that's great. I'll comment on that. We're very familiar with that method. We call it CAD on wheels. And a lot of people doing as-builts do CAD on wheels. And that is the advantage of what you all have, is you are the architect and you're working right with your client. And they are probably more all right with you being there for hours and hours and hours and coming back multiple times. We're an as-built service provider. We work for the architect. And oftentimes the homeowner is not as privy to that longer site visit.
The other thing that I would mention is that might just be me personally. I'm the class misfit, but the process of doing this, of measuring the building and spending the time there, that's how I really get to know the building.
Sure.
I understand it in ways I otherwise wouldn't. Sure.
Yeah, a lot of architects prefer to get acclimated with their project in this way, and I can't argue with that. It's a great way to get to know your structure intimately, and perhaps your clients and their hygiene habits and whatnot. But yeah, and just to comment on the measurement of the perimeter, that method is what you do if you're going to be doing the majority of your drafting back in the office. It's a fail safe. But if you're drafting in CAD on site, then it's definitely less important, because if a room measurement is 12 feet and it's popping that right out of your exterior wall, you're going to see that in CAD right away and be able to correct that problem. Sometimes it's not possible to measure a wall thickness at every spot that you need it, especially if your window has the big fat sills on either side, or you just can't open it, or there is no window. So getting wall thicknesses at every spot, we would do it as a backup, but the perimeter measurement kind of also helps us avoid that error. But if you're doing CAD on site and drafting on site, then then that would kind of eliminate the need for that for sure.
You're right about all walls. Oftentimes they're inferred, but you're working through this whole organism, and by the time you get over here to here, you see where things are and whether or not they're in an impossible place.
Some of you weren't here for the initial discussion, but Barry was mentioning Matterport walkthroughs, and that can be another tool if you don't have as much on-site time. In addition to taking good still photos, or maybe you have a 360 camera, if you want to go with a full-blown Matterport walkthrough, which you've probably seen on real estate websites like Redfin or Zillow, that can really help you get acclimated with your space, a space that, you know, maybe you're working on a project in a different state, for example. You're able to put yourself in a perspective position and then pan around 360 degrees. You can look at the ceiling, you can look at the floor, and then you can of course see the walls and the relationship to one another. So if you're looking at a set of plans or a CAD file or a Revit model on one screen, and then you're looking at a Matterport walkthrough on the other, it's the closest to what Donald's mentioned, you know, as being on site and getting acclimated with it in person.
What is Matterport?
Matterport's a proprietary software that's made by a tech company that came up with it, and it's just the name for it. It's a specific three-dimensional walkthrough. So if you go to Redfin right now, half of the house at Redfin's a real estate website. If you go there, half of the houses being advertised for sale will have a Matterport walkthrough that you can click on, and you can see that technology right then. And what it is it's not a lidar scan. It is a photogrammetry scan. So it is scanning, but it's scanning with photos and creating pictures that are relatively to scale. I'm told within a degree of about 6 inches accuracy. But the end result is a very realistic photo walkthrough that you as the user can intuitively kind of pan through and walk through upstairs, downstairs, to exterior buildings and all sorts of things. I'm going to get to you, Barry, really quick. Hold that thought, please. We'll go to Josh because he's been waiting.
Oh, thank you, Colin. First of all, could you terminate your screen sharing, because all I see is Q&A.
Oh yeah, let's do that.
Second of all, I think that those terms as-built and record drawings are in fact terms of art, and they mean something specifically. And I really appreciate your explaining that right at the beginning of your talk. I try not to refer to your work product as built because you're not the contractor. I usually refer to your product as existing condition drawings. I try to get all my clients to hire you or other firms that provide similar services, so that I have a set of existing condition drawings that I can work from. But I know that you're absolutely right. A lot of architects want to take the time to do that, the walkthrough and develop their own existing condition drawings, because they learn the building that way. So there's pluses and minuses. What I like to use your services for is for the structural aspect of a project. And in fact, I like your documentation of the structural conditions. And this one that I'm going to be talking to you about briefly, later, after I talk with the client, involves documenting specific structural elements by location. And you know, I think it's absolutely essential for that kind of project of mine that somebody like you is involved with. I don't want to take the, put in the effort to draw up the existing conditions.
Josh, you have experience with the structural aspect done with a point cloud, and what did you think?
Well, I've worked with Colin's work product several times, and I don't see the point cloud. I see the PDFs and the AutoCAD drawing. But I'm sure that they went through a point cloud at some point.
Yeah, Josh has been working with me long enough to have seen my sketch work in CAD format and my point cloud work, and hopefully it was seamless. You know, hopefully there wasn't too much of a difference in the two, because we really did try to make things accurate even back then. All right, back to Barry. You had a quick thought. I think it's about Matterport.
I was going to say Matterport also has a dollhouse kind of feature that you kind of, the roof is blown off and you see everything looking down into it. But the more important question was, if you do your point cloud, can you, at your point, be able to convert it into a Vectorworks drawing, or is it always an AutoCAD or Autodesk or whatever you call it?
No. The point cloud is just the point cloud. It's called it. You can convert it to different things, but it comes. Our native point cloud, when we've processed it, is called an LAZ file. So that's just the name of it, and it doesn't have anything to do with any software at that point.
But
So
what do you give Josh? You give Josh an AutoCAD file.
yes, because that's what.
Actually, I get PDFs. I send my production person the AutoCAD files.
Right, we create PDFs and CAD files, but ultimately whatever the client wants is the output.
The client then has to convert it into whatever they need to convert it into. Yeah. And then second question, how do you go about pricing your work?
Oh, yeah, that's a great question. There's three factors that I use. One is I take a look at the structure. I take a look at every structure individually. And the first thing is I try to get a handle on the gross square footage, find out how big it is. The second thing is the complexity of the structure. So how many levels does it have? Does it go up and down a hill? Is it shaped like a curvy octopus? How many different parts of the roof are there? I really like to look at the roof, and I rate it on complexity in several different ways. And then the third factor is just going to be the scope of work. So what architectural sheets has the architect asked for? So do they just need floor plans, or do they need exterior elevations? Do they need a reflected ceiling plan? Do they need this or that? And that's the biggest needle mover, obviously, is what type of end result productions in the software that they need.
Can you give me some numbers for a typical Oakland, Berkeley remodel of 1,000 square foot bungalow building?
I can, and I'm happy to, but let's finish. Just maybe we should bring that to an individual talk, because I just want to keep it to the pertinent as-built questions. But that's great that you want to know that, because I can happily share that with you. I do have a couple other things up my sleeve for this presentation really quick. I wanted to share in the chat, just looking at this, it looks like nobody ever took a class or had formal instruction in as-built. So I think that's going to be my calling. I think I'm going to go over to UC Berkeley and just see if they need somebody to teach this formally to students. I don't know. But it's just so strange, because it's just one of those parts of your profession where it's just everybody has learned it a different way, usually from a mentor or their boss or whatever firm they worked for, and it's expected that they know how to do it because they're architects. And some of you are wonderful at it, and some of you are not so great at it. And that's not an insult, because you have a design mindset. You're looking to design and create the future phase of the project, not necessarily reproduce an existing phase of a structure. So it's cool to see those results. I do have another question for you, but it looks like Donald's got a question. Go ahead, Donald.
I was just wondering, Colin, where you see this field moving in the future in terms of things it can't do now that it will be able to do, or tools that it doesn't have now that it will have.
Oh man, well, yeah, so it's going in an automated direction, just like several other professions. I've seen, for example, Leica is getting kind of ahead of the game. The two scanner examples I gave you, Leica and GeoSlam, are two of the front runners in the scanner industry. There's plenty of other ones, and some of them are very great. But just to compare those two, GeoSlam, from what I understand, is kind of moving into a more organic scanning direction. They're working with archaeologists that are digging in caves for artifacts and scanning things like that. Environmentalists that want to scan entire forests, and just working on making very powerful scanners that can collect organic information That's just not a rigid 90-degree type of thing. Leica has been working on attaching scanners to drones. They're coming out with something called the BLK to fly. And it's an all-in-one. Up until now, drones and scanners have been separate. You buy a great drone, and then you buy a scanner that's meant to be mounted on a drone, and there's two separate companies, and you combine that technology. Leica is actually trying to build a drone that's made for specifically for lidar scanning. And they also have a little crawling robot that can scan that they're working on, you know, which I would love to have one of those so that I don't have to get into a crawl space.
That was my next question, robots. But
Yeah.
it sounds like the drone is like a robot. Could it be used inside?
Whew, I don't know. That makes me nervous just thinking about it, but I'm sure they'll have one that's really sensitive that can be flown through a doorway and into a house. But I was getting at just, you know, combining this technology, the point clouds, with BIM, with 3D modeling software, where, you know, you're already calculating the cubic feet of concrete, for example, for a project. That's where I see the whole thing going, and really making the construction process even more efficient than it could be. You get your on-site information, and it's hyper accurate in this way with the point cloud. And then you're building a BIM model, and you're doing takeoffs, and just, you know, those change orders and waste are a thing of the past, and people are really, you know, I'm sure this has been discussed 100 times in different ways with you all, but just like the design budget growing and the construction budget shrinking, just because you're spending more time planning and actually waiting to get it done right beforehand. Really quick, I'm going to share one more time. I'd like to just take another audience question since I have you all still here. Put in the chat, how long would it take your team to measure and draft a 1,500 square foot single family residence? Using your, you know, for the 44% of you that love doing as-builts and the 10 to 12 or whatever that are comfortable with it, I'd just be curious. And let's put a scope on it. Let's say, you know, floor plans, a roof plan, and exterior elevations are what your end result is going to be. So getting that CAD file or Revit model to the point where you're happy with it. I'm curious as to what that would be. And then, so put that one in the chat, and then we have one final poll. Sydney, if you're still there, maybe you can help with this. And prior to the remodel, do you look for existing plans? Do you measure up-to-date plans using traditional methods? Do you use laser 3D scanning technology, or do you outsource your as-builts? And the poll results are coming in. I believe people are voting on that. Sorry, took that off the screen. So yeah, prior to the project, do you look, you know, do you go down to the building archives? Do you measure using traditional methods, whether it's a big sketchboard or CAD on wheels? Or do you use 3D laser scanning technology to obtain yours? Give just a couple more minutes if those stragglers want to answer the question. A couple more seconds, really.
So the Leica Disto is not what you're calling laser scanning technology, is it?
No, it's more of a point and shoot. It's a singular laser, so I wouldn't count that as scanning. Okay, I'm going to end the poll. I think all who have answered, unless you're really thinking about it. And then, yeah, just sharing the results. I don't know if you can see, but looks like a good portion of you are looking for those plans in the archives. Or going out and measuring traditionally. We have a scanner here, and then we have someone who outsources, and I think I know who that is. Okay, so yeah, just so you know, I want to, we can continue the Q&A, and I want to make a point about that last poll, but I want to thank you all for attending. I truly hope you're able to gain some insight, and perhaps I'll get the chance to collaborate with you. I've been delivering I've been working with this company for 11 years and doing as-built before that. So if you ever want a chance to see what we can do, I'd love to show you what we can do and provide some as-built plans for you. And quotes are always free. So that's my contact information if you'd like it. I'm going to stop sharing now and just talk about really quick, the plans at the archives method. The trouble with, as Josh mentioned, and as we talked about at the beginning of the program, those record drawings, if every project ended with somebody making record drawings and submitting them to the archives, I would have a lot less work. And also if those drawings were accurate, whatever's in there, I would. So you have contractors that vary from the plans, the construction documents during construction, and they obviously don't bother to update them before submitting them. And then you also have just buildings that change over the years, and you'll probably know right when you walk in if you're looking at a set of those record drawings or those archives drawings. So and even drawings that look to be accurate, we've found that they've strayed from them at some point. And a lot of clients will approach me with even a CAD file, but usually a PDF set, and say, can you use this and then do as-builts over here? Or can you add exterior elevations to this floor plan that I have? And we can't do it because the problem is we will go out and we'll try to verify some measurements. We'll take some shots with the disto and we'll look at the dimensions on the drawing, and we'll find one discrepancy. And then if we find even one, we have to start verifying every discrepancy. And if we're verifying every discrepancy, we might as well be just creating a set of plans from scratch. So that's just kind of, it's tricky to explain this to people who want to save money or time. And they say, well, we have these plans. We even got a CAD file from the last architect. And it's like, well, maybe your last architect wasn't so great at doing this, and I don't necessarily trust that CAD file. So I can't put my name on something that someone else previously worked on unless they worked for my company. So go ahead, Donald.
You're kind of getting close to a question I had, which is responsibility for accuracy and whether or not your drawings are shared. Long ago, in the early days of CAD, there was a controversy among architects as to whether or not we would give our CAD drawings to our clients. And, for liability reasons, a lot of architects said, no, if we give our CAD drawings to our client, we're basically providing a product. And then we fall under a different standard of negligence instead of if we are providing a service. So some of us still, in my contract, it says that I will provide them with PDF drawings. And if it's a project I may put some dimensions on there as needed, but I don't provide them with CAD files. If an engineer that is working with me needs it, I give it to them. If another architect comes along, I will give it to them if they give me a complete release of liability for accuracy. So, there's this question about accuracy. I'm looking at your point clouds, and what I wonder is, do you put any limitations of your liability for the accuracy of your drawings when you do a set of drawings like that professionally?
Yes, we have a pretty loose disclaimer on every set of plans. And I can't get too deep into the legal avenue, thankfully, because I don't have to. But we do try to limit our liability to whatever the client paid for the as-builts. We're not saying that if your entire project falls apart because we had a wall 6 inches over from where it should be, then I'm not sure if we should be held liable for that completely. It says something to the effect of that you need to verify this kind of thing. And and I know that's the whole point of getting as-built, so you don't have to, but thankfully we just don't have that issue ever. We just don't hear back about our plans. The only time we've had discrepancies is if somebody goes ahead and orders some finished carpentry components based on our as-builts, which they should just know not to do that. That's kind of a very hyper accurate component that should be really just kind of looked at with a finer lens. These are architectural as-built. They're not even necessarily deemed engineering as-built. They're meant to be taken to that next level by the engineer. So yeah, it is tricky, but as far as ownership of the CAD file, as you mentioned, the person who purchased it owns that CAD file. That's who it's delivered to. And I usually have no trouble if an architect calls me up and says, hey, this homeowner at 213 Hummingbird Lane worked with you. Do you have the CAD file you produced? Sometimes I'll check with the billable party if I think it might be an issue, but it's no issue just to send it on out. Are there any other questions for me about as-built or this industry that I love so dearly? Okay, well, I just wanted to share, we got some results from that last question. So more than a half day, less than 1.5 days to produce a set of as-built. That's pretty great, Donald. If you want any contract work, maybe I should call you up and see what you're doing. I got maybe some hotel. What about a hotel? How long would that take you? Standard, let's say Comfort Inn, 2 stories.
Well, it depends which suite you're going to give me.
Hey, accommodations are always provided when we do hotels. We just did the Hotel Pickwick. Does anybody know about that one in San Francisco? We just measured that hotel. It's kind of one of those classic old structures, but not that. I mean, for the price, I don't know if I would stay there. So then we got some more answers. Josh, love your answer. 10 minutes. That's good. Tim, 2 to 3 days. All right. And no one, we got someone who doesn't want to answer. 10 to 15 hours, 2 hours to draw, 48 hours to draw, 8 to 10 hours.
Sorry, I misspoke. 2 hours to measure.
Oh, 2 hours to measure. 8 hours to draw. Yeah. So if you can get a 1,500 square foot residence, confidently measured in 2 hours and be able to draft accurate floor, roof, and elevations, then you are very good.
I'm gonna hire you.
Yeah, I there's some people.
Nobody can do it accurately in that amount of time. I really don't think so.
Well, yeah, I mean, it's you'd be surprised, some of the talent that I've seen, and as long as people have an efficient method, then they can get it done. And there's different architectural styles too. Are we talking about a Tudor? Or are we talking about, one of those, brutalists?
There's also
I'm not putting in any of the electrical outlets or the light fixtures.
Sure, that was predetermined in the question. I said,
take photos, and then if I miss something when I'm measuring, I can usually recreate it from the photographs.
Yeah. So yeah, it's always a curiosity to me to find out, how long it takes people. So thank you so much for answering that question. And
well, I mean, there's also the matter of different architects have what you might call a different standard of care or a different way, degree of accuracy or degree of detail that they put in their work. And so that may account for some of the different architectural styles. So Colin, there must be other companies that do what your company does.
mm-hmm.
Would you expect a similar kind of variation in the quality of the work, the accuracy of the work, the way they do it?
Sure. I mean, there is, and I have seen it, but I will say that, the majority of the work I've seen from competitors has been great. And there's, we've even collaborated with other as-built companies before. It's not a fiercely competitive industry. I'd say where my company PPM stands out is just the service. We kind of are known for that and taking our clients through it completely, scheduling the on-site visits a little better and more efficiently, and just having a more comprehensive deliverable and after the project response and things like that. So I think that's where we shine above, but we're definitely not known as the cheapest or the fastest. Definitely the degree of quality is there. And there are, hacks as there are in other industries as well. that you'll want to watch out for. But for the most part, I've had great experiences with others and seeing their work as being impressive.
Can you hear me? I don't even know if I'm on.
Yes, I hear you.
I'm just curious, can you give us a sense of what we're looking at? A sense of, I love doing it, but it's sometimes at some points in some projects, it's just really, or the time involved, it'd be great to depend on something. What kind of range are we talking about for, like, let's say the 1,500 square foot home, or, like I do most of my work on the East Bay. So just a regular kind of house where you're going to do an addition, or you're going to do some remodeling or something. What if I didn't do it? What am I looking at here, time-wise or money-wise, roughly? Just to range from very simple to a little bit more complex, or just to get a general sense.
Yeah, great question. I think we can get into that now if there's not any other questions. But yeah, I'll say, first of all, my goal is always to be less than you. So an architect's hourly rate to go out and measure this thing and then come back and draft it, or stay out in the field and draft it on wheels. I always am striving to be less than that, because that would kind of eliminate the whole point of it as well, and save you the time and save you the energy and let you concentrate on what you want to do. So that's the end goal. And, I want to meet budgets too. So whatever price I slap on it, if somebody were to come back and say, we're really trying to budget this much for the as-builts, can you do it? I'll try to find a way to do it. Having said that, I mean, a 1,500 square foot house, in general, if you want floor plans, roof plans, and exterior elevations, that scope that we just discussed, which is our most basic, most common scope asked for, it's going to be somewhere around $1 a foot. So $1,500 out the door for the field visit and the deliverable. That's probably where you're going to be. And then if the scope goes up with precision, the price will go up slightly if you want to see all those little outlet covers and things like that. Go ahead.
But when you say deliverable, are we talking about something that I have Vectorworks also, but is that something I can directly use, or I still have to translate a PDF to Vectorworks?
In the case of my company, Vectorworks is one of the holdouts that we have not started offering right now. We offer 4 softwares. We offer CAD, Revit, SketchUp, and ArchiCAD. Those are the 4 that we're offering right now.
Yeah, but Vectorworks can import DWG files.
Right, so wouldn't, yeah.
That's absolutely right. I know that there's importing. I have several clients that use Vectorworks, so I'll say that right off the bat. I know that there's issues bringing a DWG straight into Vectorworks. You lose all your layer discrepancies. You lose a lot of the different things. But if you want to do a little bit of back end work and get it nice and polished up and ready for your project, then it absolutely works. And I do have several clients that use Vectorworks.
But let's say you could have done that. That means what a deliverable would be. I have it in my program.
Yes.
Vectorworks.
Yes.
So how soon are you going to get Vectorworks into?
I've been asking. We have meetings where we say what's going to be the next one. And who wants, with our team that does drafting and modeling, who's going to learn this thing? We got to get a copy of it. We got to have somebody really delve into it and learn the thing, because we're not going to offer it unless we, have an expert on staff. So it's a discussion that we've done every year. So we did Revit. We started using scanners at the end of 17, beginning of 18. That's when we purchased our lidar scanners and started scanning. So up until then, it was all Sketch and all CAD. Then we started offering Revit shortly after, because that was the most demanded software next to CAD. And then we started polling our clients. Josh may have gotten one of these polls, but we started polling clients and talking to people and all sorts of things like that. I think that's when we made the decision to add ArchiCAD. Because ArchiCAD seems to be an alternative for people who hate Autodesk and want to get away from their subscription program. It's a very, and I think that's what that company is latching onto. They're like, yes, you have the freedom. You can get ArchiCAD and do 3D modeling, and you won't be subject to this subject.
Excuse me, I should get in here just a little bit, because we reached the end of our time.
Oh yeah.
And I all of us A round of applause, Colin. That was a very interesting and informative program. We really appreciate you taking the time to do it.
You got it. Absolutely. Thank you so much.
Okay.
So yes, that discussion will be had about Vectorworks. That's, and you know what, shoot me an email saying, Colin, please offer Vectorworks, and I can show it to my boss.
Okay,
Okay. Great. Good to see everyone.
same
All
here.
right.
Thanks a lot. Hi, Donald. Anyway.